Welcome to Fibonacci and Freitag magic squares. There's been a fascination with Fibonacci numbers and magic squares spanning centuries, with both, in the days of numerology, having a mystical aura. In more contemporary times, interest in magic squares is seen as a form of recreational mathematics, despite such luminaries as Euler and Ramanujan making contributions. The Fibonacci sequence, on the other hand, is regarded as an object of serious study and has applications in such fields as computer science and plant biology. Even the magnificent doorstop, the Princeton Companion to Mathematics, features on its cover a nautilus seashell with the curves of its chambers described approximately by Fibonacci spirals. A method for converting Fibonacci numbers into magic square numbers was discovered by Herta Freitag, an Austrian-American mathematician. Her method, or algorithm, is offered here in a lightly treated manner, the only skill required for understanding being the ability to add four numbers together. Now for a very quick primer. Look at this sequence of numbers, 0, 1, 1, 2, 3, 5, etc. Notice how for almost all of them, each number is the result of adding the two previous numbers. For example, 5 is equal to 2 plus 3, and 89 is equal to 34 plus 55. This is the celebrated Fibonacci sequence. The Fibonacci sequence has a close relative, the Lucas sequence, defined as 2, 1, 3, 4, 7, etc. The Lucas sequence has a starting number of 2, but once we get to 3, it follows the same Fibonacci prescription. 3 and subsequent numbers are the sum of the previous two. So 11 is equal to 4 plus 7, and 322 equals 123 plus 199. The relationship between the two is shown in this diagram. At the 7th position in the sequence, the Lucas number is 29. The Fibonacci numbers at sequence positions 6 and 8, when added, also equal 29. So on to magic squares. There are many and bewildering square varieties, but we'll only concentrate on this 4x4 example. Select the first 16 natural numbers, 1 to 16, and arrange them in a square table such that all the rows, columns, diagonals, and other combinations of 4 cells each sum to 34. This is the magic number, or constant, for this square. And there are numerous other 4-cell combinations, such as these, each adding to the magic number 34. In her paper, A Magic Square Involving Fibonacci Numbers, Herta Freitag introduced it by way of this 4x4 magic square. Add the individual rows, columns and diagonals and they all sum to 233, the magic number for this square. But the majority of numbers, coloured in blue, are not individual members of the Fibonacci sequence. They are in fact the sum of two non-consecutive Fibonacci numbers. So for example, 110 is equal to 21 plus 89, and 39 is equal to 5 plus 34. There is an exception, 16, which is equal to 2 times the Fibonacci number 8. So Freitag's magic square involves Fibonacci numbers, and is the nearest thing to a pure Fibonacci magic square. The general prescription for building Freitag's magic square is this. So, for example, if A was equal to 5, then we'd find that the 13th number in the Fibonacci sequence, 233, is the magic number, and all the cell values are assembled from the 8 Fibonacci numbers preceding it, in accord with her clever algorithm. Herta Freitag's method can also be applied to the Lucas sequence. Corresponding to the 13th number in the Fibonacci sequence, 233, is the Lucas number, 521. Using this as the desired magic number and applying Freitag's algorithm, we get this 4x4 Lucas magic square. The rows, columns, diagonals, and other combinations, such as the 4 centre cells, all sum to the Lucas number 521. And the red diagonal contains 4 of the 8 preceding Lucas numbers. Spreadsheets lend themselves to the construction of Freitag magic squares. Enter a suitable Fibonacci number, in this instance 610, which is 15th in the Fibonacci sequence, and stand back. Just for fun, relevant cell values in the spreadsheet were generated with AI prompts via a proprietary interface rather than applying the usual spreadsheet functions. But because the embedded prompts were scattered around the sheet and I couldn't remember where they were all located, I turned to GPT-4 to create some JavaScript code for the display of their cell addresses and their contents. So whether it's only of recreational interest or otherwise, there's something satisfying when two venerable mathematical entities are connected. Thank you for viewing this video.